Hello everyone, welcome to the lecture series on PLC programming. In today's video, I'm going to explain the concept of up counter in PLC. At the first place, let us look at the symbol of up counter. Having seen the symbol, we all have to think about why it is named as up counter and what is a counter at the first place. So counter is basically a device that is used to count some values, isn't it? But why is it used in PLC programming? That is a big question. So it is used in PLC programming mainly in food and packaging industries where you might have 300 water bottles and you have to count each one of them. And after counting 300 water bottles, you might have to do a certain operation, and that is where up counter will be used. So, not specific to up counter or down counter, it totally depends on the scenario. But when we are talking about up counter, it is used to count the values in an incrementing fashion. For example, if you want to count 5, so it starts from 0 and counts up to 5 in an incrementing fashion. Whereas if you're talking about down counter, it counts in the reverse direction. So each one has their own requirement in different applications. But let us first look at the working of an up counter with respect to PLC programming. So we have seen the symbol, and if you carefully observe, there are several different parameters over here, and it is necessary to note down each one of them and what are they used for, so that it is very easier for us to understand the working. So at the first place, if you carefully observe, counter is represented as C5 colon 0, and this will indicate the counter number and counter file. So the reason why it is very important is because you might have multiple counters and you have to uniquely identify each one of them. In a program, if you have 3 to 4 counters, this can be only identified based on the counter number. And C5 basically indicates the file number. So there will be designations or positions allocated in the memory where you have to use this particular number in order to utilize the address of that particular PLC. That is why this is very, very important. So please make a note of it. So preset value is pretty simple and straightforward. This is the count value that we want, and that is what we will be setting so that we achieve that count value. Whereas accumulated value basically keeps counting the count values and indicates the overall count. So if we want to visibly see what is the overall count that has taken place, then that can be seen using accumulated value. What are CU and done then? So CU indicates count enable and DN indicates done bit. So count enable is basically quite similar to the timer enable bit that was used, and done bit is quite similar to the on delay timer done bit. So we're going to look at the working. So let's get started. So there is a common question, how does an up counter work, isn't it? So in order to understand in a better way, let us consider a typical example where we want to turn on this particular light after 3 counts. So the preset value is 3 if you carefully observe. And how do I achieve this? So this is achieved in a simpler manner. Initially, when I like assume that I have a push button switch, and once I press the push button switch, the normally open contact becomes energized and acts as short circuit. Consequently, the rung gets energized, the up counter gets energized, and as a result, once the up counter is energized, the enable bit basically goes high. Count enable bit goes high instantly once the up counter is energized. So it counts one value, that is the accumulated value will now become equal to 1. But when you use a push button switch, once you press, the count value will be counted, but at some point in time you will release it, isn't it? So when you're releasing that push button switch, it becomes red because it acts as normally open, and there is no contact between the supply terminals and the up counter, and it acts as open circuit at this point in time. Again, when you press the push button switch, what happens? This again gets energized and count value of 2 is counted. Again, when you press the push button switch, count value of 3 is counted, and after 3 is counted over here, consequently the accumulated value is equal to the preset value, and when this happens, the done bit goes high. I hope this point is clear. So the enable bit, it just follows the input. If it is input is high, the enable bit will be high. If the input is low, the count enable bit will be low. Whereas done bit will keep on counting the values, and once the accumulated value is equal to the preset value, then the done bit will go high. Now, if you carefully observe, the address of the done bit with respect to the up counter is used over here, C5 colon 0 and done. So if you have another counter and you want to use an address, so in order to avoid confusions when you have multiple counters, this address plays a very important role. I hope this point is clear. Now since this goes high, this will also go high, isn't it? Because I'm using the same address. Consequently, the rung gets energized and the light starts glowing in this particular fashion. So basically what we were able to achieve in this case, light turns on after 3 counts. In this particular application, I used a push button switch and I pressed it 3 times in order to have 3 input counts, and the light will turn on after 3 inputs that I've given. Like basically I have to press the push button switch 3 times. But whereas in PLC programming in industries, you don't have to manually do these things. There are automatical processes. So it keeps counting based on the scenario and it will give you the output value. So as a whole, as a conclusion, if you have to see, count enable bit goes high instantly, done bit goes high only after counting or only after having the accumulated value equal to the preset value. Important conclusion, because these are the ones that we will be comparing with respect to down counter as well. Having seen this, one of the most important concepts is the timing diagram. This is important because at times, even if you're confused with the concept, because there will be up counter, there will be down counter, on delay timer, off delay timer. So these are all different concepts. And if you know the timing diagram, you can arrive at the concept on your own. I'll tell you how. Let us look at the timing diagram with respect to the bits. So we basically had an input, the push button switch that we used, and I counted 3 values, and that is why it goes high and then comes back to low in this particular fashion. So 3 counts is given over here, and I'm extrapolating so that you can draw the other waveforms as well. What happens to the count enable bit? As I told you, it just follows the input. So you can blindly draw this. And what happens to the accumulated value? In each of these count scenarios, it was just counting the values, isn't it? So once a count of 3 is reached, it goes to high state. What happens to the done bit then? Once the accumulated value is equal to the preset value, that is after 3, it goes to high state in this particular fashion. So now from this diagram, you can look at the done bit, you can look at the count enable bit. So from this, you can arrive at a conclusion that the done bit goes high only after the accumulated value is equal to the preset value. And that is where the timing diagram plays a very, very important role. I hope this point is clear. And I hope you were able to understand the concept of up counter in PLC. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. Please do keep supporting. Thank you.